today's lecture, we will apply the methods that we have learned in solving differential equations into word problems. Okay, this is our first application. The problem is you have a tank and it is initially filled with 100 gallons of salt solution. So you have the tank, and then this is filled with 100 gallons of salt solution. So this is the 100 gallons is the volume. Gallons is a unit of volume. Okay? Containing 1 pound of salt per gallon. 1 pound of salt per gallon. So that is the concentration. 1 pound per gallon. Meaning concentration is amount of solute, which is in the problem is salt, over the volume of solution. Okay, over the volume of solution. Okay, so this is a given. And then fresh brine containing 2 pounds of salt per gallon runs into the tank. Okay, so you have two pounds of salt per gallon. By the way, brine is just salt water solution at the rate of 5 gallons per minute. 5 gallons per minute. So this is the volume flow rate that is coming into the tank. And the concentration of the solution is 2 pounds per gallon. 2 pounds per gallon. And then, and the mixture assumed to be kept uniform by stirring. So you have a agitator, stirrer inside the tank, and runs out at the same rate. Okay, so the same rate, so the same volume flow rate, 5 gallons per minute. Okay, so there is a fresh brine that is coming into the tank at 5 gallons per minute, and then there is also a solution coming out, which is at 5 gallons per minute. What is asked in the problem is find the amount of salt in the tank at any time t. Okay, so we let Q be equal to the amount of salt in the tank at any time t. Therefore, ang pangayo sa problem is what is Q sa function of time. Okay, this is the equation that will relate the amount of salt in the tank as a function of time. And then another one is how long will it take for this amount to reach 150 pounds. Okay, so ilang oras daw or minuto ma-reach niya ang 150 pounds of salt in the tank. Okay, so how do you solve this problem? First, you need to find a solution equation that would relate Q and among all the given parameters here. Okay? Okay, so if we will have mass balance in that tank, okay, let's apply mass balance in the tank. Okay, so the amount of salt in the tank is just the amount of salt that enters the tank minus the amount of salt that is going out of the tank, right? Okay, so I will not erase this one. Okay, so this is our equation. We apply mass balance. Okay, mass balance. Amount of salt in the tank is just equal to the amount of salt that enters the tank and the amount of salt that leaves the tank. Okay, but since ang given natin dito is Q dot. No. Dito Q dot, this is VI dot or volume flow rate. Okay, A sub O dot. Okay, so how do we relate the volume to the mass? We'll use the concentration. Okay, concentration of the salt that enters the tank, AI, is just Q sub I over V sub I. Okay, therefore Q sub I is just CI VI. And then we will differentiate this one. Ano naman? Why? Because rate, this is volume flow rate, so we will differentiate this one with respect to time. Okay, you have dq over dt is just minus over dt. Okay, and then this term is just, if we differentiate this one with respect to time, you have now the concentration is just constant, so it becomes CI dVi over dt. What is this one? This is just equal to VI dot, or the volume flow rate, which is this one. Okay, so we'll now have CI. What is your concentration? 1 pound per gal times 5 gal per minute. Okay, minus minus this term, the amount of salt that is going out of the tank. Again, this is just equal to CO VO dot. Okay, so what is C sub O? C sub O is just, again, concentration is just amount of salt over the total volume. Okay, total volume. Okay, total volume. Okay, so what is the total volume of the tank? The total volume is just 100 gallons. 100 gallons na naman. Why is that? Because the same flow rate that enters the tank also leaves the tank. Therefore, there's no increase in volume of the solution. This is just Q over 100. Okay? So this becomes Q over 100 times 5. Okay? This is equal to Q over 20. Right? So minus Q over 20 dQ over dt. Okay? I'll now erase this one. So what is now our equation? You have dq over dt is just 5 minus q over 20. Okay, 5 minus q over 20. So we will, so this becomes 100 okay, so determine what type of differential equation is this one. Okay? Oh no. 2 pound per gallon. 2 pound per gallon. No. Oh no. Okay. Okay, so by the way, this is not 1 pound per gallon, this is 2 pound based on the problem. Okay, based on the problem. So this is 10. Okay, based on the problem, the fresh brine enters the tank at 2 pound of salt per gallon. So this is 2. Okay, this is 2 pound per gallon times 5, the volume flow rate. Okay, so this is now 200. Okay, that is 200. Okay. Okay, there is two ways of solving this one. You can solve this as linear ordinary differential equation or as a variable separable, because we can separate the variable q and t. So if we use variable separable, we have dq over 200 minus q is equal to dt over 20. Okay, and then integrate this one, we have negative ln 200 minus q is equal to 101 over 20 over 20 plus c. Okay, t over 20 plus c. And then we put this negative sign into the equation. And you have 200 minus q raised to negative 1. Okay, raise this to e. You have 1 over 200 minus q minus q is equal to e to the t over 20c. Okay, or this is just equal to 200 minus q no, this is just equal to 200 minus q over 1 c e to the t over 20. Okay, or you can rewrite this one as c. Okay, sundan. Actually this is 1 over c, right? But 1 over constant is just constant. We will again we will try to solve using this one later on. Kung same lang ba makuha mo ng answer if you use this one or if you use this one. Okay? Therefore, again, ang objective natin is to find an equation that will relate q and time. So this will become q is just equal to 200 minus c e. Okay? That's it. And then, using the boundary condition, we will try to find the value of c. What is our boundary condition? At time is equal to 0, initially, how much is the amount of salt in the tank? The amount of salt in the tank is concentration, which is 1 pound per gallon, times the volume, which is 100 gallon, which is therefore initially the amount of salt in the tank is 100 pounds. Okay, so we will substitute that one. We'll erase this one. Therefore, Q is equal to 200 minus C E is equal to 200 minus C. Therefore, C is just e to the 0 is 1. Okay, therefore C is just 100. C is just 100. Therefore, your equation will now be 200 minus tama? Okay. That's it. This is now the equation that would relate the amount of salt with respect to time. Okay? Now, if we use this equation, okay, will we still arrive in this solution? Let's see. Okay, you have 200 is equal to 100 minus Q is equal to 1 over C e to the negative t over 20. Okay? Therefore, your Q is just 200 minus 1 over C. Okay, substitute the boundary condition. Okay, therefore 1 over C is just 100, or C is just 1 over 100, and then we will substitute that here. 200 minus 1 over 100 okay, we have seen that you will also arrive at this equation even though you use this one or this one. Okay, that is because we substitute the boundary condition. Okay, so that is the idea behind why sometimes we have this one, but we equate it to C during our solution. Okay, because you will still arrive at the same equation. Okay, how about the time where Q would be 150 pounds? Okay, so it's just simple, just substitute it here. Okay, you have 150 plus 200 minus 100. Therefore, you have 50 over 100 E negative T over 20. So you have E negative T over 20 cos 1/2. Apply ln. Therefore, negative T over 20 is cos ln of 0.5. What is ln of 0.5? Therefore, T will be T is equal to 13.9. The unit is minutes. Okay, minutes. Why minutes? Because the flow rate that was given is gallons per minute. Okay, so that's it. Okay, let's have another application wherein we will apply the methods in solving linear ordinary differential equation. Okay, so let's model a mass spring system. Okay, mass spring system. Okay, so what are the applications of this one? So actually we can apply this one in analyzing car suspension, and also almost all objects behave as a mass and spring system. Okay, like your house. Okay, this is your house. You can actually model this one as mass and spring system. Okay, that's it. So hindi lang ito limited sa car suspension or those involving springs or masses, but actually we can apply this to sample a what do we call this one, tower. Okay, sentry tower. Okay, so you can model this one as mass and spring system. Okay, so what is the effect of wind in this type of structure? Okay, you can analyze that one using mass and spring system. Okay, so the simplest one is this one. You have a spring that is initially unstretched and stretch, and then at a certain time you put a mass. Okay, so kinabitan mo ng mass. So the result, na-elongate yung spring. Say for example S sub O. S sub O yung length. Okay, but there is still no motion. The spring here is just in equilibrium position. Okay. How about if you pull this one? You pull this one. If you pull this one at a distance y, okay, you pull that one and then release. So you will now have a oscillating motion, okay, or simple harmonic motion. So the spring will elongate, compress, elongate until such time that there is no energy left, then it will go back to this position. Okay, so how do we analyze this one? Okay, we analyze this one by applying Newton's second law of motion. It states that summation of forces along the vertical, we assume that the mass travels vertically, no? It's equal to mass times acceleration, or y double prime, right? Okay, so if we assume positive downward. Okay, let's take the downward direction as a positive. Okay. So what are the forces acting here at your mass? You have the gravity, mg, and the force of the spring, Fs. Now this is just equal to K times the elongation, which is, this is the elongation, S sub O plus Y. So you have mg minus K S sub O plus Y is equal to M Y double prime. Okay? Okay, so you have mg minus k so minus ky. Okay, but kso based on this one, if we apply Newton's first law, since this is in equilibrium, there's no motion. Okay, so what are the forces involved here? You have force of the spring, which is K times SO, and mg. Therefore, mg is just equal to K times S sub O. Therefore, this whole term here will become 0. Okay, this is now your equation, differential equation. This is linear homogeneous ordinary differential equation. Okay, for, again, this is for undamped system. What do you mean by undamped? There is no damping force. Okay, there is no damping force. However, there is, wala talagang ganito na object in real life, because there is always a damping force. Okay, there is always a damping force. Air, what is a damping force? Ito yung mag-oppose sa motion mo. Okay, kung pa-download ang motion ito, and air particles actually is a damping force, no? So, meron talagang damping force. Although, there are times na pwede mo siya i-neglect dahil maliit yung contribution niya, like yung air. Okay, this is for undamped system. Undamped system. Okay, I will now erase this one. Okay, if you have this differential equation, how do you solve the general solution of this one? So, we will apply the methods that we have learned in solving linear homogeneous differential equation. You divide this by m, you have y double prime plus. Okay. Let's find the characteristic equation. Characteristic equation is this. Okay. We will not use m for the characteristic equation because meron na tayong m dito. So we will use lambda. You have lambda squared plus k over m. Okay, so our characteristic equation is lambda squared plus k over m. So you have your roots is just positive, negative, square root of k over m. Okay? Ano? K square root of k over mi. So how do you get the general solution? The general solution is just complex roots. So you have a cosine square root of k over m x x ba ito? T actually a cosine, okay, because a function of time ito, it's a function of time, plus b sine square root of n t. Okay, now this term, this is what we call the natural frequency. Natural frequency square root of k over m. Okay, square root of k over m. So this becomes y is equal to a cosine omega sub o t plus b sine omega sub o t. Okay, natural, this is natural frequency. Okay, so for a simple harmonic motion, meron tayong tinatawag na, let's define some terms like period. Ang unit ng period is in time. Okay, time. Like seconds or minutes. Time ang unit niyan. Okay, so if you have this, this is the graph of a cosine. Okay, this is a graph of a cosine. So itong length na ito yung period. Okay, that is the period. Okay, from this position, babalik ka sa the same position. Okay, or from one interval. Ang length na ito is what we call the period. Now the frequency is just the opposite of period. By the way, ang period mo is denoted by okay, this is 1 over period. This is just the reverse of the period. So ang unit nito is 1 over second or cycles. Ano? Hertz. 1 over second is hertz. It's hertz. Okay? Now for this one, since this is a trigonometric function, sabi dito ang period ng isang trigonometric function is, ang period niya is just 2 pi over omega sub O. Ito yung period ng undamped system mo. Okay? Dahil mag-oscillate man yan. Ang frequency is just opposite of period. So you have omega O over 2 pi. Yan ang frequency ng oscillation mo. So kung tinatanong sa problem, what is the frequency of oscillation ng iyong system, you use this one. Okay? This is for undamped system. So we will proceed with systems which has damping forces. Okay? So anong sample niyan? Okay. Ito yung shock absorber mo. Okay? Now if the spring in the problem, sa first illustration natin, pag nilagyan mo yan ng what we call a dash pot. Okay, this is a dash pot. So ano yung dash pot? Okay, so kung sa shock absorber mo ito, meron kang sa loob ng shock absorber mo, meron yung spring, merong piston. And then this piston pushes against a oil or a viscous fluid. Okay, ano ba ang purpose nun? So that ma-control niya ang movement ng iyong spring. Okay? And ma-absorb niya ang impact ng lupa doon sa iyong sasakyan. Okay? So ano mangyayari doon sa equation mo? If we apply the Newton's second law, okay, Newton's second law. So, ang free body diagram mo ngayon, you have the force of the spring, Fs, and then you have Fv, or the viscous force. Ito yung dahil sa pag-compress mo sa fluid. Okay? So, what will happen is that you have ano mangyayari sa equation mo ngayon? Again, yung notation natin is positive downward. You have K. Now, yan, you have mg minus ky, force of the spring, and then minus c. Now, itong viscous force, ang value nito is just c times the velocity. C times the velocity. Ano ang velocity? That is just dy over dt. Is the velocity, or cy prime is equal to my double prime. Okay? So, the same. By the way, this one is, kung ibalik natin yung kanina, this becomes KSO KSO plus Y. Magdagdag ka lang ng force due to damping. Again, this will be cancelled out, so remain, ang equation mo ngayon is just Y my double prime plus CY prime minus KY, so transpose mo sa kabila, magiging plus KY is equal to 0. That is now your equation. Again, this is second order linear ordinary differential equation. So, if we divide this one, you have y double prime plus cm y prime plus k over my is equal to 0. Right? Now, your characteristic equation will be lambda squared plus c over m lambda plus k over m is equal to 0. How do you find the roots? You will apply the quadratic equation. So you have the roots will be lambda is equal to negative b, negative c over m plus minus square root of b squared. So you have c over m squared minus 4ac over 2. Okay? And then what would happen to this one? You have negative c over 2m, negative c over 2m this is 1. Now we will simplify this one. So you have square root of c squared over m squared. Becomes square root of m squared c squared minus 4m k. Now ilabas natin ito, del squared ito. This becomes plus minus 1 over 2m square root of c squared minus 4mk. Tama? Okay, tama. This is your lambda. Okay? Now, if we let alpha be equal to c over 2m, beta be equal to 1 over 2m square root of c squared minus 4 mk. So this will become lambda is equal to negative alpha plus minus beta. Okay? So yan lang siya. Now, again, there are 3 cases for this one. Case 1, diba? Yung sa roots. If c squared is greater than 4 mk, you will have real roots. This is what we call overdamping. Overdamping. Case 2 naman, when c squared is equal to 4 mk, this is what we call critical damping. Yung makuha mo na roots dito is double root. Real double when c squared is less than 4 mk. So complex root ang makuha mo nito, which we call underdamping itong case na ito. Okay, so the same method lang sa pagkuha, just like yung sa mga examples natin, pagkuha ng roots and how to find the general solution. Okay, just follow the step. Ang importante lang is how to set up the differential equation. Doon lang yung mahirap na part. Okay, how to set up the differential equation. So there are samples in the book, you can check. Okay, thank you.